In this video, we're going to have a look at an A-star level question on integration. So just from first sight, you might have spotted that when you differentiate x cubed, you get to 3x squared. So perhaps integration by substitution might work. Now, if you do use that, then we'd replace u with the denominator. So x cubed plus x squared minus 5x plus 3. And if you differentiate both sides of the equation, we get that du dx is equal to 3x squared plus 2x minus 5. Is there any way to manipulate this so that we can replace the numerator with anything related to this? Well, if you multiply it by 2/3 to get to 2x squared, 2x multiplied by 2/3 is 4/3 x. So it doesn't really work out. You can't really replace the numerator with the differential. And that tells you that you actually don't use integration by substitution. By the way, very sorry if you can hear an alarm in the background. But how we actually do this is, well, it's giving you a bit of a hint here. You want to first focus on factorizing this, and then you deal with this as partial fractions. You break this up into partial fractions and integrate those individual partial fractions. So let's focus on factorizing this. Let's start by letting f of x equal this whole function. We now need to find a root of the function because we know that if f of a is equal to 0, then x minus a is a factor of the whole cubic. So we need to find a factor somehow. You always substitute in values between -5 and +5. We can start at 0, so 0 plus 0 minus 0 plus 3 is not 0, so that's not a factor. What about 1? So f of 1 is equal to 1 cubed, which is 1, plus 1 squared, which is 1, minus 5 times 1 plus 3, which actually ends up equaling 0. So that means that x minus 1 is a factor of this whole cubic. What we can then do is divide the whole cubic by long division, and we can divide it by the factor that we just found, x minus 1. So I'm just going to quickly write that out. So just a recap of how to do that. To go from x to x cubed, you multiply by x squared times x is x cubed, x squared times minus 1 is minus x squared, you then subtract. That cancels out the x cubed terms. X squared take away minus x squared is x squared plus x squared, so that's 2x squared. You then bring the minus 5x down and you rinse and repeat the process. So to go from x to 2x, you multiply by 2x. You can skip a few seconds if you'd like. I'm just going to quickly write this out. And 2x times minus 1 is minus 2x. Subtract all of that. Minus 5x plus 2x is minus 3x. And then we have plus 3 here. To go from x to minus 3x, you multiply by minus 3. And then, we just write the rest out. Minus 3x plus 3. That all cancels out to 0. That means that this cubic can be split up into x minus 1 and x squared plus 2x minus 3. You might have already spotted this, but this second bracket, we can actually factorize this even further. We can say that this is x plus 3, x minus 1. You might have also noticed that two of these brackets are the same, so we can write this out as x plus 3 multiplied by x minus 1 all squared. And just in general, we can now write out this whole integral as the integral of 2x squared plus x plus 1 all over this 3 brackets, so x plus 3 and x minus 1 all squared. Now, in order to integrate this, we first separate this massive fraction into 3 individual partial fractions. Because there's a repeated factor of 1, we say this can be written as a over x plus 3 plus b over x minus 1 and then plus c all over x minus 1 all squared. Before we compare the numerators, we need to make it so that the denominator of each of these fractions match the denominator in the actual answer. So in this first fraction, you have to multiply top and bottom by x minus 1 squared, so that this denominator is also x plus 3, x minus 1 all squared. So the numerator becomes a, lots of x minus 1 all squared. I'm kind of speeding through the partial fraction side of things. If you'd like me to make a separate video, just let me know. In this second fraction, you not only multiply by x plus 3, but you also multiply by x minus 1 to make this denominator match this one. So we also do that to the top of the fraction. B, lots of x plus 3, x minus 1. In this third fraction, it's already x minus 1 squared. You just need to multiply x plus 3 to top and bottom to make it so that the denominators match. And then you can make all of that equal to the numerator of the fraction in our answer. So that's 2x squared plus x plus 1. Now we need to substitute in values of x strategically to eliminate terms. So if you put x equals 1 in, that eliminates this, and this term allowing you to solve for c. So let's do that. When a equals 1, well, 2 times 1 squared is 2, plus 1 is 4. That's equal to, like I mentioned, this term cancels out, this term is also 0. This term here is, well, 1 plus 2 is, sorry, I'm just going to have a quick look at one thing in the question. Yeah, that's fine. Okay, so 1 plus 2, oh, that's why. This is supposed to be x plus 3, right? Because to go from c over x minus 1 all squared and have the denominator match this denominator, we need to multiply by x plus 3. I actually wrote x plus 2. So do be a little careful. It's very easy to make little mistakes like that. How I spotted that was you end up with a weird fraction when you put x equals 1 into this. Now that you put x equals 1 into this, 1 plus 3 is 4, and 4 times c is 4c, and you can easily get that c equals 1. Yeah, sorry about that. Do keep an eye out. If instead you replace x with minus 3, that cancels out the b term because minus 3 plus 3 is 0, and also the c term because minus 3 plus 3 is 0 again. Minus 3 take away 1 is minus 4. When you square minus 4, that's minus 4 times minus 4, that's 16a. And that's equal to the left-hand side, which is, well, 2 minus 3 all squared is 9, 2 times 9 is 18, 18 take away 3, and plus 1 is 18 take away 4, sorry, 18 take away 2, which is 16. Meaning that a is just actually equal to 1. Now there's nothing else we can substitute in for x to eliminate terms of a, b, and c. So what you can do next to find the value of b is look at coefficients of x squared on both sides of the equation. So let's do that. The coefficient of x squared on the left hand side is just 2. That's equal to the coefficient of x squared in this term. When you expand this out, this will be ax squared, so that's a. When you expand this out, it will be bx squared, so the coefficient of x squared is b. This has no coefficient of x squared. Since we already know a is 1, we can then find b by just substituting a equals 1 into this, and we get that b is also equal to 1. Now that we got values of a, b, and c, we can say that this whole fraction here is equal to 1 over x plus 3 plus 1 over x minus 1 plus 1 over x minus 1 all squared. So the integral of the left-hand side is the integral of each of these individual parts. As the final part of the question, we just want to integrate these 3 individual parts. So and join them together. So let's call this option 1, option 2, and option 3. So option 1 is the integral of 1 over x plus 3. Now when the numerator differentiates to the denominator, or let's say the other way around, sorry, when the denominator differentiates to the numerator, then the integral of that is ln of the denominator. So the official sort of rule for that is, I'm just going to write out here. When you're differentiating something that where the numerator is a differential of the denominator, that's equal to ln of the denominator when you integrate it. So that's what we are applying here. Same with the second one. X minus 1 differentiates to 1. So when you integrate all of this, it's ln of the denominator, ln of x minus 1. But this third term is a little bit more different because when we differentiate x minus 1 all squared, well, when you expand this, it will be x squared minus 2x plus 1, which then differentiates to 2x minus 1. That doesn't match the denominator at all. And actually, this, to deal with it, it's best if you replace the bracket with a singular letter like u. That's what tells you that you use substitution. So the integral of 1 over x minus 1 all squared with respect to x. Let's start by replacing the bracket with u. U equals x minus 1. In this case, that becomes 1 over u squared dx. I'm just going to replace this with u to the minus 2 dx. This is not in terms of u yet, so we can differentiate both sides of this equation. Du dx is equal to 1. Multiply both sides by dx, so du is equal to dx. And you can replace dx now with du. So this becomes integral of u to the minus u du. When you're integrating, you add 1 to the power and you divide by the new power. So that becomes minus 1 over u, or just minus 1 over what we expressed as u in the initial start of the question, minus x minus 1. And then, like I mentioned, you just join all 3 of those together. So your final answer is ln of x plus 3 plus ln of x minus 1 minus 1 over x minus 1. And you can put plus c as well because it's indefinite integrals and there's no limits involved. Very difficult question, more long than anything, honestly, but it combines loads of different concepts. There's a bit of factor theorem, long division, partial fractions, integration by substitution, and integration using this formula here. Thanks for watching, and be sure to like and subscribe. I have another A-star playlist on the description that you can check out if you have time. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.